Welcome back to another exciting episode of Godot XR for beginners. In the last video, we created grab sockets and we also added a bounce factor to the ball, but we ran into an issue where the tiles were just creating some issues for us. They're a little bit too thin. Fortunately for us, we did these tiles in such a way that we can easily change them. So I've got them over here and I've actually made them a little bit thicker. So what we're going to do is I'm just going to make this box shape 1 tall, and we'll set its transform to 0. And instead of using these floor meshes, we'll just go ahead and add our own child node, a mesh instance 3D. And the mesh will be a box. So, cool. If we go back to the Test XR Toolkit, we'll see everything is all boxes. And we'll just go ahead and get rid of this that never got saved as a prefab. And we'll just duplicate one, move it into its place. Now, this is cool, but the problem is it doesn't line up perfectly. And it's also not in the right position now. So I think what we're going to do to make our lives easier is we're going to write an editor script. And it's going to just create a simple hollow cube around the player so that they can throw the bouncy ball. And I think it'll be pretty fun. To easily place our cubes, we're going to make something called an editor script. And all it's going to do is just place the cubes for us in an orderly manner that allows everything to line up nicely. So to start, we're just going to delete all these floors that we have placed ourselves. Now we don't have a floor. So we still have the parent node flooring. So what we're going to do is we're going to go into our file system here on the bottom left. We're going to create a new script. We're going to call it world map spawner. Sure. Oh, looks like I already made one when I was messing with it. We'll just call this one cube map spawner. Good enough. So we have cube map spawner. It's not going to extend node. It's going to extend editor script. And the first thing we're going to do is we're going to make a variable for our cube tile. And it's going to equal this floor that we have created. So I'll just drag that in like that. And then we are going to make some variables to hold the size of the cube. So we'll say cube size or say map size equals, we'll start with 6.0. So that'll be, so we're going to make that an integer so that we have a, we don't end up with a decimal number of cubes ever. And this is going to be a 6 by 6 square on each side of our cube. Okay. And then for editor scripts, well, the first thing that we need to do is we need to go at tool up here so that it can run in the editor. And then we're going to make a function called run. And this is what runs when you run an editor script. So these are special scripts that you run from the editor that don't actually run inside the game. So for now, I'm just going to print, this is my swag editor script 6.7. Because I'm cool. So we'll just go ahead and try to run our cube map spawner. And look at that. This is my swag editor script 6.7. So that's how you run an editor script at the basic level. Now let's get it to do what we want. What we want this to do is spawn a grid of cubes. And before we can spawn a grid of cubes, what we need to do is write a function that will spawn a single cube. So to write a function, all you have to do in the script is write the keyword func, just like that. It'll turn red. Then you can name the function whatever you want. I'm going to name it spawn single cube. And then you can tell the engine if there's any arguments that the function should take in. So I'm going to say I need to be able to take in a root node and a parent node and the position that I want to spawn the cube at. And you'll get a red line. You can type pass. That'll just add some code underneath this so that it is a complete function. So let's go ahead and call our function that we just wrote. First thing I'm going to need to do is come up with the arguments that I'm going to pass into the function. So we'll start by declaring the root variable. And this one, I'll just get the editor interface and I'll get the root node. And the next one will be the parent. So I'll just grab the flooring node right here. Okay, and then for the position, I will start off by just setting it to 0. So now all I have to do is just say spawn single cube root parent position. So this will call the function, but it won't do anything right now. We still have to fill in the function with what we actually want it to do. So let's make this function spawn a cube. So I'm going to say var cube instance equals cube tile dot instantiate, and we'll just leave that blank. Then we're going to call our parent, and we're going to say add child, and we're going to add the cube instance as a child to our target parent. Then for it to show up in the editor, we need to set its owner to the root node of the scene. And finally, we will just set its position. Perfect. So now when we run this, we should see a cube show up in our viewport and in the node tree. And look at that. We got one floor node. And in our viewport, we also have our floor node here. So if we continue to run this script, we'll see more floor nodes, but they'll all be in the same position. So what I want to do is create an entire floor using an editor script. So in order to do that, I'm going to have to write a loop and modify the position each time within the loop. So let's see what that looks like. So instead of declaring position up here, I'm going to just declare an X position, a Y position, and a Z position. Oh, wrong language. Okay, so then I'm going to say for X in range 0 to -3 to 3. So X pause equals X. And then we will say for Z in range -3 to 3. We'll say our Z pause equals Z. Okay. Up here, we'll say this equals 0 for now. And right here under the loop, under the second loop, we're going to move our spawn single cube right under there. And instead of position being set up top, we'll set it inside of this loop. Just like that. So what this should do is go and make us a 6 by 6 floor essentially. So let's try that out. So, oh, I'm sorry, a 7 by 7 floor is what we, oh no, 6 by 6, okay. Because the range will go from -3 up to -2. So here we go, a 6x6 floor. So if we go ahead and apply the same principle to these other axes, we can make a nice hollow cube around the player. But for now, let's just run a quick test and make sure our floor is acceptable. Okay, so I'm able to walk on the floor, that's good. Let's try to bounce the ball. And the ball looks a lot better than it did on our hand placed tiles. They're thicker, so they catch more collisions. That means we'll be able to do kind of higher speed collisions without having to worry too much about it. Still a little bit of weirdness on the bounce. We'll have to look into how to fix that. Now, before we get too crazy, we do need to clean up after ourselves when we're spawning tiles. So if we ever regenerate tiles, we want to delete the ones that we spawned in. And that's as easy as just grabbing the target parent and clearing out all the children from underneath. So we'll say for child in parent dot get children child dot queue-free. So that'll get rid of all of these extra ones that we've spawned here. So if I go ahead and run it, now you'll see we always keep this a fixed size. So I can run this as many times as I want, and it'll just regenerate all of these tiles without generating over the top of them and having all this data cluttering up your computer. So now what I'm going to do is I want to go ahead and spawn, we're going to do another several loops to spawn all the sides of this cube so that we're standing in a fully enclosed environment. So to do that, we're going to need to generate each side of the cube. So we'll have 6 double-nested for loops in total. This will be good practice if you're going to be writing loops. Thank you very much. I'll post this into the comments so you can copy this. So now we're going to do the cube. So I'll and that's looking better. So it starts at 0 and it moves its way out. So now what I got to do is I just got to move my little table that I've created here. Move it kind of like in here. And then the ball, we'll move the ball so it's on the table still. And then of course my player, we'll move them so that they are in play. And let's go ahead and just finish our last loop before we test it. So we got all this. I'm just going to copy this block here. Perfect. So now we've got this kind of fully enclosed cube that encapsulates the player. Let's see how that looks in VR. Wow, okay, this is pretty cool. It appears that I am stuck, unable to move. Okay, so it looks like dragging the player up just a little bit fixed my problem. I'm no longer stuck. I'm able to move around the cube, and I can throw my bouncy ball, and it should bounce around the inside of my cube. Awesome. So, where'd my bouncy ball go? Oh, there it is. There it is. So, if you haven't tested in your headset in a while, now would probably be a fun time. You know, see what it's like to have this bouncy ball that you can just throw around in this room. And then we'll come back and we'll focus on making it into something of an actual game. When considering a design for the actual gameplay of this tutorial game, the first thought that came to mind was the old game Q-bert. So I think what we're going to do is go for a Q-bert inspired minigame where you bounce the ball off of the walls and essentially try to illuminate the entire room. To make that happen, we're going to need to modify our floor prefab so that it lights up when it's hit by an object, and if it's already lit up and it's hit by an object, it goes dim again. So we're going to need to make kind of a toggle block effect for that. So let's go ahead and add a script to the floor node. But before we add our script to the floor node, one thing you're going to need to know is that static bodies are not going to be able to report collisions because they're just kind of something to collide with. So what we're going to want to do to make our lives easier is we're going to add an area 3D node to our tile so that we have a way of detecting collisions. I'm going to go ahead and just copy my collision shape 3D and add it here. And I'll just rename it and get rid of the 2. So now we've got this area 3D that we can connect to. So with that area 3D, we're going to go ahead and add a script to our floor. I'll name it floor.gd. And what we're going to do is we're going to say func on hit. And we'll add a node to that. And we'll pass. So then in the area 3D, we'll go node, we'll go to signals, and we will have a body shape entered, or a body entered. So we'll use the body entered. So we'll connect that to our floor. We'll pick, I'll say on hit, and connect it. So now we're connected to this on hit function. So what we're going to do from here is we're going to say if node is rigid body 3D, because right now the only rigid body 3D that we have is the bouncy ball. We're going to print I'm hit. That way we can just look at the print statement and view simply if we've detected a collision or not. So then the last thing I'm going to do is I'm going to take this collision shape 3D, I'm going to make it unique, and I'm just going to make it a tiny bit bigger so that the ball can collide with it before it actually bounces off the tile. So we'll go 1.01 and alright, so it's just slightly bigger. So now if we go into our testing, we should see print statements populate in our output as the tiles are hit. So let's just see, make sure that we're getting that reaction. Alright, okay, so it looks like we're getting that I'm hit signal getting printed out as our ball bounces around. That's good. Alright, so the first thing we gotta do now that we are listening for collisions is we have to give this some sort of way to change color to indicate that it's on or off. So what we need to do is we're going to need to access the meshes material. So we'll say var mesh equals, we'll just drag this in. Ah, yes. When we do that, we got to say on ready var mesh. And then we can drag stuff in. So then the other thing we got to do is we got to say material equals mesh dot get active material, and the surface will just be 0 because there's only one surface. So on ready, we're going to have to create a unique instance of the material and assign it to this tile. Otherwise, when you change one color, they're all going to change. So we'll access the ready function, which is built in and it runs anytime a node enters the scene tree. So here we're going to say mesh.set surface override material 0 is going to be material.duplicate. So now it's just going to take a copy of whatever the material is in this, and it's going to duplicate it to create a unique copy of that. So we'll be able to grab this later, and in fact, perhaps we should store our unique material here. That way, we are sure to be able to have access to it when we need it. And then we'll just pass that in instead right here. So this should work exactly the same way, except for let's go ahead and create a material. So I'll just go into my folder and I'll create a new resource, and we'll just call it, we'll get a standard material 3D, and I'll just call it tile material. So we've got this tile material. Now we can click on our mesh instance and we can just drop that material right in, right there. So now our tiles are going to be white. And I can make them whatever color I want by modifying this in the material slot. So for now, I'll just make them like a dark blue. Sure. So this will kind of be the off color. So if I go back into my test, everything's off. It looks kind of nice, but it's probably going to be somewhat dark. So let's just make sure that everything runs well here and that we didn't mess up our script. All right, looks good. Looks like everything's getting assigned correctly. And we've just got this random cube that is not a tile. That's okay. So we're still not changing colors. Let's go ahead and write the part of the script that will cause this to change colors. So here I'll say var on color will be a color equals color dot chartreuse, and set the off color dot want something dim, but I don't want it completely black. Indigo, I mean it's a bright color, but it's not chartreuse. I'm colorblind anyways, what does it matter? So now we're going to write a toggle color function, and we're also going to need to set a flag. We'll say is on, and we'll set that to false at first. And here, our unique material, we're going to set the albedo to the off color. And that way, it should get set to indigo right when it's spawned in, and they're all off when they're spawned in. So here, when we toggle the color, we'll say is on equals not is on, like that. So that should negate it, and so if it's false, it's going to become true. If it's true, it's going to become false. You get it. And then we're going to check if the tile is on. If it's on, we're going to say the unique material dot albedo is going to equal the on color. Otherwise, we're going to set it to the off color. And that should apply right to the mesh because the material is the same material as the one that's already in the override. And all we need to do now is on hit, instead of printing I'm hit, we'll toggle the color. Now let's give that a shot and see if it works. Okay, so looks like nothing's happening. That's really cool. It's ugly, but you can pick your own colors. And when I throw the ball around, everything that it bounces off of changes color. It still occasionally flies through the wall, but we will have to fix that in another episode. So there we go. The ball bounces around and everything it touches toggles. So the challenge is to have the ball touch every surface without hitting it an even number of times. So kind of a Q-bert effect, if you will. In the next episode, we will fix that issue where the ball occasionally bounces through a tile, and we'll also just kind of improve the bounce physics overall via scripting. And we're also going to add some lighting and glow effects to these tiles to really make them pop. So I hope you enjoyed this video. If you liked it, please give it a like, and if you like the channel, please subscribe.
Welcome to the Big Dog, once a training vessel for the U.S. Air Force parachute